Hello friends, welcome to my YouTube channel. Today we are going to learn permutation. In this lecture, we learn about factorial, fundamental principle of counting, permutation, permutation under certain condition, permutation of objects not all distinct. Now, first see factorial. Factorial. What is factorial? The continued product of first n natural number is called n factorial. The continued product of first n natural number is called n factorial. It is denoted by n factorial, or it is denoted like this way n factorial, or this way n factorial. That is n factorial or n factorial equal to 1 into 2 into 3 into n minus 1 into n. This is the continued product of first n natural number. For example, 4 factorial. 4 factorial equal to 1 into 2 into 3 into 4 equal to 24. N equal to 4. N equal to 3. Now 3 factorial equal to 3 into 2 into 1 equal to 6. Now we see deduction of factorial. How to deduct a factorial? N factorial equal to 1 into 2 into 3 into n minus 1 into n. Now 1 2 into 2 into 3 into n minus 1 up to we can write n minus 1 factorial. So n factorial equal to n minus 1 factorial into n. That is equal to n into n minus 1 factorial. This is the deduction. Now similarly you can deduct to the next term up to n minus 2 up to n minus 3 and many more things. Now note, here is a note. Some value of 1 factorial is 1 and second note is 0 factorial. Value of 0 factorial is 1 because 0 factorial defines only equal to 1. Proper now note third, factorial of proper function or negative integers are not defined. Factorial of proper fractions or negative integers are not defined. Now fourth note is factorial is defined only for whole number. Factorial is defined only for whole number. Now here is a question for your practice. Find the value of given factorial and operate. Here is given some factorial and its given operation of factorials. Now first question is 15 factorial divided by 14 factorial. Second question is 4 factorial plus 3 factorial. Now third question is 5 factorial minus 6 factorial, and fourth question is 9 factorial into 22 factorial. Now fifth question is 9 factorial into 2 factorial plus 3 factorial divided by 6 factorial minus 2 factorial into 4 factorial. Now I have done for you. First question is for you factorial 15 by factorial 14. Now you can factorial 15 deduct up to 14 factorial. 15 into 14 factorial. Now 14 factorial get cancelled. Yeah, you can expand this term. 15 into 14 into 15 factorial equal to 15 into 14 into 13 into up to 1. Now similarly you can deduct into expand into 14 into 13 into 12 into up to 1. So we can cancel the all the term up to 14. We have remaining only 15. So 15 factorial divided by 14 factorial is equal to 1. Similarly you can solve another question for addition. How to add? Now you can expand all the 10, put the values 4 factorial and 3 factorial, then add these. Similarly you can third question done in subtraction. put the value of 5 factorial and 6 factorial, then subtract. Fourth question you have solve by putting the value. Similarly you can solve fifth question. Now second question, find the value of n if. First question, if n plus 2 factorial equal to 415 in 50 into n factorial. Now second question is 9 plus 1 factorial equal to 12 into 9 minus 1. Find the value of n. What is the value of n? So you can solve, operate. I have one done for you. First is done for you. See that how is it solved. N plus 2 factorial equal to 450 into n factorial. Now expand the term n plus 2 factorial. N plus 2 deduction of factorial n plus 2 into n plus 1 into n factorial. We can write n plus 2 factorial equal to n plus 2 into n plus 1 into n factorial equal to 450 into n factorial. Now n factorial got cancelled. Now n plus 2, and now remaining n plus 2 into n plus 1 equal to 450. Now multiplying, and after multiplying both product, now we get n square plus 3n plus 2 equal to 450. Now subtracting 450 both side, we get n square plus 3n minus 448 equal to 0. Now n equal to, we get plus 19.60105 19.66010105 and minus 22.66601. This is not acceptable because factorial value of factorial is never negative. So answer is n equal to 19.66. Now you can solve also this way. Second question, here in second question, n plus 1 factorial deduct up to n minus 1 factorial. Now then you can solve it. Now third question is, prove that 2n factorial divided by n factorial equal to 1 into 3 into 5 into 2n minus 1 into 2 to the power n. Means here is odd number multiplication into 2 to the power n. Similarly here is second question, 2n minus 1 factorial divided by n factorial equal to 1 3 5 1 into 3 into 5 dot 2n minus 1 dot n plus 2n plus 1 into 2 to the power n. Now third question is, n factorial divided by n minus r factorial equal to n into n minus 1 n minus 2 into n minus r minus 1. Now we solve third question. Third question is, n factorial divided by n minus r factorial equal to n into n minus 1 and n minus 2 into n minus r minus 1. Now n factorial divided by n minus r factorial equal to n into n minus 1 into n minus 2 into dot 2 into 1 divided by n minus r factorial. Now we can expand this written in this way. N into this term is written in this way, equal to n into n minus 1 into n minus 2 into dot n minus r term comes lies between the here and into dot 2 into 1. Now divided by n minus r factorial. Up now this term numerator is written, equation 1 is written here. Now n into n minus 1 into n minus 2 dot n minus r plus 1 into n minus r into n minus r minus 1 into dot 2 into 1. Similarly you can write n minus r plus 1 equal to n minus r minus n minus r minus 1. You can write this term in n minus r minus 1 equal to n minus r plus 1, right, in this way. So you can get it like this way, n into n minus 1 into n minus 2 into n minus r minus 1 into n minus r into n minus r plus 1 dot 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 2 into 1. Now n minus similarly we can write by arranging like this way, n into n minus 1 n minus 2 into dot 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 n minus r minus 1 into n minus r into dot 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 up to 1. Now n minus r into up to 1 you can write n minus r factorial, say equation 2. Now we get n minus 1 into n minus 2 n minus r1 into n minus r2, we say equation 2. Now this equation 2 put in equation 1, put the at the numerator value. Now we get, put the equation 2 in equation 1, we get n into n minus 1 n minus 2 into n minus r minus 1 into n minus r factorial divided by n minus r factorial. Then get cancel n minus r factorial equal to n into n minus 1 into n minus 2 dot 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 n minus r minus 1. Answer. Hence this is proved. Third question is proved. Similarly you can prove this question third first. Question number 3 of first question. You can expand 2n factorial and now separate out term and even term, we get like, then after you get cancelled n factorial and now remaining only 2 to the power n and out term. So you can prove this way first question. Similarly you can similarly if you done this question, then you can able to solve this question. If you have any problem, first try to yourself, then ask in comment box, then I will give you explanation. Now fundamental principle of counting. There are two fundamental principles of counting. First is fundamental principle of multiplication and second is fundamental principle of addition. First, fundamental principle of multiplication. What is the fundamental principle of multiplication? If there are two jobs such that one of them completed, if there are two jobs such that one of them completed in m base, if there are two jobs such that one of them completed in m base and when it has been completed in any one of these m base, it has been completed in any one of these m base. If there are two jobs such that one of them completed in m base and when it has been completed in any one of these m base, second job can be completed in n base, then the two jobs in succession can be completed in m cross n base, means m into n base. I hope you got it, understand the principle of multiplication. If you don't understand, I will give you an illustration so you can easily understand. Now I will give you an illustration of fundamental principle of multiplication. Let's suppose in a class 10 boys and 8 girls. In a class 10 boys and 8 girls. Teacher wants to select a monitor of this class, a boy and a girl. In a class 10 boys and 8 girls, teacher wants to select monitor of this class, a boy and a girl. In how many ways can teacher makes the selection? In how many ways teacher makes the selection? In a class 10 boys and 8 girls, teacher wants to select monitor of this class, a boy and a girl, in how many ways can teacher select the makes the selection? There are 10 boys in a class and 8 girls. In how many ways teacher makes the selection? If I want to select a boy monitor, so how many number of ways? 10 ways. 1, 2, 3, 4. If anyone 10 out of from 10 boys select anyone, get completed my first work. Then if I select anyone girl from 8 girls, it complete second work in 8 ways. So select a boy in 10 ways and select a boy in 8 ways to complete this both tasks. So when you have selection done by both, if you select a boy and then select a girl, so how many ways we have? 10 into 80 ways. 10 into 80 ways. Here teacher perform two jobs, selecting a boy and selecting a girl. Boy perform 10 ways and girl perform 8 ways. So the required number of ways to complete performance 80. So required number of ways to perform to complete this performance 80. This task is complete only when selection performed by the fundamental principle of multiplication. Okay, I hope you all are understand. Note: principle of multiplication can be extended for any finite number of jobs. Principle of multiplication can be extended for any finite number of jobs. Let us suppose up to n, that is j1, j2, j3 jn. You have performed jn jobs. Now then its way to perform batch to complete task. J1 jobs complete in m batch, j1 2 jobs complete in m2 batch, and jn batch completes in mn batch. To complete all the tasks, to perform action of all jobs, so total way equal to m1 into m2 into m3 into into m1. Now we learn second fundamental principle of counting is fundamental principle of addition. If there are two jobs such that they can be performed independently in m and n ways. If there are two jobs such that they can be performed independently in m and n ways respectively, then either of two jobs can be performed m plus n ways. If there are two jobs such that they can be performed independently in m and m ways respectively, then either of two jobs can be performed m plus n ways. Then either of two jobs can be performed m plus n ways. If you don't understand this statement, so I will explain you by the illustration. Let's suppose in a class there are 10 boys and 8 girls. Similarly, previous like illustration. Teacher wants to select a monitor. Teacher here wants to select a monitor. In previous illustration, teacher wants to select a girl monitor and a boy monitor. In a class there are 10 boys and 8 girls. Teacher wants to select a monitor of this class. Is either a boy or a girl. Here is select a monitor, either a boy or girl. If I have selection a boy or select a girl for monitor, then my task is going to complete. I perform both two tasks to select a monitor from girls or boys. So in how many ways teacher can select a monitor? There are 10 boys and 8 girls. In how many? For select a selection of a boy monitor is 10 ways and selection of girl a monitor is 8 ways. So how many number of ways to complete the task of select a monitor? 18 ways. If I select a boy from 10 ways, you have done. Now similarly, if you select the total number of ways equal to 18 to select a boy or a girl. Here is a teacher perform 2 jobs, selecting a boy, selecting a girl. Boy perform, girls perform 10 ways, 8 ways. The required number of ways to complete performance either boy or a girl equal to 18 ways. Now conclusion. What are you conclusion from this two fundamental of what are you conclude from 2 fundamental principle of counting? Now here is a conclusion. If to complete jobs task gives the sense of and if you want to complete job or task, you gives you the sense of and, then we can apply fundamental principle of multiplication. If to complete jobs task gives the sense of and, then we can apply fundamental principle of multiplication. When we apply fundamental principle of multiplication, when to complete jobs gives the sense of and. Now second conclusion is if to complete jobs task give the sense of either or, then we can apply fundamental principle of addition. When we can apply fundamental principle of application, if to complete jobs give the sense of either or gives the sense of either or as like in previous illustration. In fundamental principle of multiplication, we give the and sense to select a monitor a girl and boy and sense. And in second illustration, in fundamental principle of addition, to select a monitor either a boy or girl, Okay, I hope you all will understand. Now here is given to you practice question. A room has 6 doors. In how many ways can a man enter the room through one door and come out through a different door? Here is a room which has 6 doors. In how many ways a man can enter the room and one door and come out through a different door? Means a man enter in a room, then enter from one door, then comes out from room through another door, not the same door. So how many ways to man can enter the room through one door and comes out through different door? Now you have 6 doors in a room, then enter from a door, then you have remaining 5 doors. So enter 1 and remaining 5 into 5 into 1, 5 into 1, 5 into 1 up to 6 times, then add it. Means to complete a job to to perform job of entering in a room, I have 6 ways, and to perform comes out from the room from different door have 5 ways. So you can to complete enter and out from room task to gives you the and sense. When you complete both, then task is going to be completed. So you can apply the fundamental principle of multiplication here. So total required number of ways equal to 6 into 5. 6 into 5. Entrance wage is 5 and comes out wage is 8. If I only 5, I have remaining 5. Why? Because I have entered from this door, then B cannot comes out from this door. So I have only left 5 doors. Now next question is, given 5 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? Give 5 flags of different colors. How many different signals can be generated if a signal requires the use of 2 flags? A signal requires the use of 2 flags. I have given 5 flags of different colors, but I want to generate different signals by using 2 flags, one below the other. Now, so how many ways, how many different signals can be generated? So how many different signals can able to generate? Can be generated? So first we required 2 flags. We require 2 flags to generate a signal. So we require 2 flags to different signals, but I have 5 signals. So first select a flag in 5 ways, then select remaining flags to make a signal in 4 ways. So one signal is generated in by using 5 into 4. So total number of a signal is generated is 20. Total number of signal is generated into 20. To complete sense, we use gives the AND sense here to complete this task. Now explanation of this question. Given 5 different signals, 5 different flags. For making a signal require 2 flags. Here is a box for making a signal, flag 1 and flag 2 signal. We require 2 flags for making a signal. So first flag choose in any flags to make a signal. I have 5 ways. Then second flag choose from remaining 4 flags to make signal. I have 4 ways. So required number of signal equal to 5 into 4 by the fundamental principle of multiplication. Now here is given question for your practice. I have give you an explanation and solution of previous 2 questions, so you can solve these questions by yourself. I have just read out. Third question is, there are 6 multiple choice questions in an examination. How many sequence of answer are possible? There are 6 multiple choice questions in an examination. How many sequence of answer are possible if the first 3 questions have 4 choice each and the next 3 have 5 each? Now similarly, 4th question is, how many numbers are there between 100 and 1000 in which all digits are distinct? 4th question is, how many numbers are there between 100 and 1000 in which all the digits are distinct? Now 5th question is, how many numbers are there between 100 and 1000 such that 7 is in the units place? How many numbers are there between 100 and 1000 place such that 7 is in the units place? Now 6th question is, a gentleman has 6 friends to invite. In how many ways can we send invitation card to them if he has 3 servants to carry the card? A gentleman has 6 friends to invite. In how many ways can we send invitation card to them if he has 3 servants to carry the cards? Now 7th question is, by using the digits 0, 1, 2, 3, 4 and 5. Repetition not allowed. Numbers are formed by using any one of digits. Find the total number of non-zero numbers that can be formed. By using the digits 0, 1, 2, 3, 4, 5. Numbers are formed by using any number of digit. Find the total number of non-zero numbers that can be formed. Repetition not allowed. Now, permutation. What do you mean by permutation? Each arrangement which can be made by taking some or all of a number of things is called permutation. each arrangement which can be made by taking some or all of a number of things. Each arrangement, permutation means arrangement, each arrangement which can be made by taking some or all a number of things, something or all a number of things is called permutation. For example, if there are 3 alphabets A, B, C, then the permutation of taking 2 at a time. If there are 3 alphabet A, B, C, then permutation taking 2 at a time. I have 3 alphabet A, B, C, then how many ways to arrange by using 2 alphabets? How many ways to create arrange these alphabet by taking 2 alphabets only? So here is arrangement. First I will take AB, then BA, then BC, CB, AC and CA. There is the 6 arrangements are possible. Note, it should be noted that in permutation the order of arrangement is taken into account. It should be noted that permutation the order of arrangement is taken into account. When the order is changed, a different permutation is obtained. Means here is in permutation noted that the order of arrangement is taken into account. Means here is the order of arrangement is accountable. When the order is changed, a different permutation is a different arrangement object. When we put A in first place, then here is put in second place, create different arrangement. A, B and BA. Similarly, BC and CB create different arrangements, and AC and CA create different arrangement. Different permutation is obtained when placed at first place at A and first place of C. Then if first place kept at C, first place at C, then second place A gives another arrangement. Now, notation of permutation. N P R of P N R like this way, where n belongs to integer, and R belongs to integer, where R is from 1 to n, 1 to n. R is from 1 to n up to n, not more than 1. Not more than n. R is possible up to n. Total number of all permutation of n distinct things. That means total. This notation means total number of all permutation of n distinct things taken R at a time is denoted by the symbol PNR or NPR. Now PNR or NPR equal to n factorial divided by n minus R factorial. N factorial divided by n minus R factorial. Now, theorem first. Let R and n be positive integers such that R is from 1 to n. Then the number of all permutation of n distinct things taken R at a time is given by, let R and n be positive integers such that R from 1 to n. Then the number of all permutations of n distinct things taken R at a time is given by n into n minus 1 into n minus 2 into n minus 3 n minus R minus 1. That is P and R equal to n into n minus 1, n minus 2, n minus 3 into n minus R minus 1. For proof, now take an arrangement 1, 2, 3, 4 up to Rth term. We have n things and arrangement is possible up to R. Okay. So first arrangement is in n base. Similarly, you can arrange it n minus 1 base. First for proof. Now we have R box and arrangement of n things. Now first box in arrange in n ways, second box arrangement is possible in n minus 1 ways, and third is n minus 2 ways, means n and then n minus 1, n minus 1, similarly n minus 2, similarly n minus 3 for n 4 box arrangement n minus 3. So here is n minus r minus 1, similarly n minus r minus 2, r minus 2. To complete arrangement filling, apply fundamental principle of multiplication. To complete arrangement of apply fundamental principle of multiplication. So np are equal to n into n minus 1 into n minus 2 into n minus 3 into n minus r minus. To complete all arrangement, apply fundamental principle. When you arrange all things, then you get complete this task. Hence the total number of permutation of n distinct things taken are at a time is n into n minus 1 into n minus 2 into n minus 3 dot 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 n minus r minus 1. So Pn are equal to n into n minus 1 into n minus 2 dot 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 n minus r minus 1. Proved. Now second theorem, prove that Pn are equal to n factorial divided by n minus r factorial. In this previous theorem we have proved Pn are equal to n into n minus 1 into n minus 2 into n minus r minus 1. Now multiply and divide by n minus r into n minus r plus 1 into dot 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 up 1 up to 1 into up to 1. So Pn are equal to n into n minus 1 into n minus 2 into dot 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 n minus r minus 1 into n minus r into n minus r plus 1 dot 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 2 into 1. Now n into n minus r up to 1 is n factorial. N into n minus 1 dot 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 up to 1 equal to n factorial. Now n minus r divided by multiply and divided by this term, then n minus r into n minus r plus 1 dot 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 3 to 1 equal to n minus r factorial. Hence Pn r equal to n factorial divided by n minus r factorial. Now theorem 2. Theorem 3. The number of all permutation of n distinct things taken all at a time is n factorial. The number of all permutation of n distinct things taken all at a time is n factorial. That means total number of permutation of different things for all taken at a time is r equal to n. When we have taken n things from n distinct things, by using theorem 2, Pn r equal to n factorial divided by n factorial r. Here r equal to n, so Pn n equal to Pn, put the value of r equal to n. Now n factorial divided by n minus n factorial equal to n factorial divided by 0 factorial equal to n factorial divided by 1, because the value of 0 factorial equal to 1. So n factorial. Hence Pn r equal to n, means hence the number of all permutation of n distinct things taken all at a time is n factorial. Remember it. Now here is for your practice question 6p2, 8p4 and p15-7. Okay. Now first is solve for you 6p2. 6 factorial divided by 6 minus 2 factorial equal to 6 factorial divided by 4 factorial. You have already solved how to solve these factorials. So here is 4 factorial. When deduction of factorial, we get 6 into 5 into 4 factorial divided by 4 factorial. 4 factorial got cancelled equal to 30. Answer. Okay. Now another question 8p4 you can solve by yourself. P57 solve yourself. Now second question is, if Pn4 equal to 20, Pn4 equal to 20 into Pn2, find the value of n. Oh, good question. Now how can you solve this question? Let's Pn4 equal to 20 into Pn2. Now expand. permutation. N factorial divided by n minus n minus 4 factorial equal to 20 into n factorial divided by n minus 2 factorial. So n factorial got cancelled. Now multiply this term in RHS. Now we get 1 equal to 20 into n minus 4 factorial divided by n minus 2 into n minus 3 into n minus 4 factorial. We can expand this n minus 2 factorial. We get n minus 2 into n minus 3 into n minus 4 factorial. So n minus 4 factorial, n minus 4 factorial got cancel. Then go to the LHS. This term goes to the LHS. N minus 2 into n minus 3 equal to 20. Now expand this term. N square minus 5n plus 6 equal to 20. Now after solving we get n minus 7 into n plus 2. We get n square minus 7n plus 2n minus 4 equal to n minus 7 into n minus 2 equal to 0. Now n equal to minus 2 and n equal to 7. N equal to 7 is acceptable, minus 2 is not acceptable. Why? Because we know that n is integer, always positive whole number. This is possible only for whole number, not for negative integer. Hence n equal to 7. Now third question is P54 equal to 2 into P6R minus 1, find R. Here is a third question, similarly like previous second question. So you can solve by yourself. If you have any problem, then ask in comment box. Note, here is given notes for remembered results, and then if you wish to prove yourself by yourself by expanding LHS and RHS. Now you can already prove in junior classes how to prove LHS and RHS. Okay, so here is a 4 results. Pnn equal to 2 into Pn n minus 2. Similarly Pnn equal to Pn n minus 1. Now you can remember it, just for you remember. Okay, next. Now here is given to you practice question. In how many ways 4 different rings can be worn in 5 fingers with the most one in each finger? In how many ways, first question is, in how many ways 4 different rings can be worn in 5 fingers? In your hand you have 5 fingers and I will give you 4 different rings. So how many ways you can worn 4 fingers in 5 4 rings in 5 in your 5 fingers. So you can put your ring 4 rings one by one in 5 fingers. So how many ways you can? Required number of ways equal to 5p4. How many way of arrangement can be possible? 5p4. How many number of permutation is possible? 5p4. N equal to 5. Why? We have 5 fingers. Here have 5 n things and a arrangement of rings in your 5 finger is 4. R is equal to 4. So 5p4 equal to 5 factorial divided by 5 minus 4 factorial. We get 5 factorial divided by 1 factorial equal to 5 factorial. We get 5 factorial. So equal to 5 factorial value is 120. Now similarly another question, second question, in how many ways can 6 person stand in a queue? In how many ways can 6 person stand in a queue? I hope you got understand this question. So solve by yourself, try to solve. Okay, I will tell you an explanation of this question. Here is a 6 person and 1 queue. Here is a 6 person and 1 queue. Here is a arrangement of 6 person in a queue. In how many ways? Here is arrangement is possible in 6 person at all distinct in n distinct means 6 factorial. Here is answer is 6 factorial. Here is a queue where persons can be arranged in a row, in a queue. Here is queue is 1 So how many ways you can arrange? You can wage is 6 factorial. Okay, because here is n equal to 6 and r equal to 6. Now similarly, third question is, it is required to sit 5 men and 4 women in a row so that the women occupied the even place. How many such arrangements are possible? Third question, it is required to sit 5 men and 4 women in a row so that the women occupy the even place. How many such arrangements are possible? There is a 5. How many seats are required to sit 5 women and 4 5 men and 4 women in a row such that the women occupy even place. Women occupied even place. So how many such arrangement are possible? Let's suppose here is a seat. Total okay. Total number of seat is even position occupied by women. Women. So here is a 5. Okay. Men, women, women. Like this way. So in women's arrangements are possible. For seat 1, 2, 3, 4. Here you have 4 seats at even position. 4 seats at even position and 4 women. So you can play arrangement possible by 4 factorial. Arrange selection of women, arrangements of women, 4p4 equal to 4 factorial. Now similarly remaining seats are 5 and women's are 5. So arrangement of women is 5 factorial. So we complete this task, apply the fundamental principle of multiplication. Required number of arrangement is possible equal to 24 into 120 equal to 2880 ways. So now you can put so you can also apply. Here is a 5 man, first seat is given to you man, out position given to you man in 5 ways. Now here is even position gives to you women at, so how many ways? 4 ways. Now similarly men at out position, so get 4 ways. Now for women 3 ways at even position. Now for men 3 ways. Now even position for women 2 ways and out position for men 2 ways and even position and even out position of for man 1 way. So you can to complete this task you can apply by the fundamental principle of multiplication. So you can multiply, we got this value, then you multiply 5 into 4 into 3 into 2 into 1. Okay, this is 5 factorial and 4 into 3 into 2 into 1, this is 4 factorial. Like similar you can do this like way and by this way, you have got same answer. Now fourth question is, there 3 men have 4 coats, 3 men have 4 coats and 5 waistcoats and 6 caps. In how many ways can they wear them? This is for your homework. Oh, try to solve. If you have any problem, then ask in comment box. Now fifth question is, this is for your homework also. In an examination hall, there are 4 rows of chairs. Each row has 8 chairs, one behind the other. There are 2 classes sitting for the examination with 16 students in each class. It is desired that in each row, all students belong to the same class and that number 2 adjacent rows are allotted to the same class. In how many ways can these 32 students be seated? In an examination hall, there are 4 rows. Each row has 8 chairs, one behind the other. There are 2 classes sitting for the examination with 16 students in each class. It is desired that in each row all the students belong to same classes. It is desired that in each row, all our students belong to the same class. That number of two adjacent rows are related to the same class. In how many ways can these 32 students be seated? Okay. Now, here is note: permutation under certain condition. Permutation under certain condition. First condition under the permutation is the number of all permutation of n different objects taken are at a time when particular object is always included in it in each arrangement. The number of all permutation of n different objects taken are at a time when a particular object is to always included in each arrangement is. How to solve this question? R into n minus 1 p r minus 1. Now second condition is the number of permutation of n distinct objects taken are at a time when a particular object is never taken in each arrangement. The number of permutation of n distinct objects taken are at a time when a particular object is never taken in each arrangement is n minus 1 p r. N minus 1 p r. N distinct object taken are at a time when particular object is never taken in each arrangement. Now third condition is there are no permutation of n different objects. The number of permutation of n different objects taken are at a time in which two specific objects always occur together. Two specific objects always occur together is 2 factorial into r minus 1 into n minus 2 p r minus 2. N minus 2 p r minus 2. Now, here is practice question for you. Now, how many different words can be performed with the letter word equation so that? Here is a question. Good question. Here is given the letter of the word equation so that. So, how many words can be formed? And in this question, so that the words begin with E. The words begin with E. The words begin with E and end with N. The word begin and end with consonant. Okay. Now, solution of this question is the given word contains 8 letters in which 5 are vowels and 3 are consonant. Vowels are A, E, I, O. All vowels are here. And consonant A, T, N. In first questions, we have given fixed in equation how many numbers of words form when equation words like equation words begin with E. So from the equation letters, how many words can be formed when begin with E? Here is a condition. E is fixed. He is fixed means E is always occurred. Like condition is always occurred. Like first condition is always occurred. So you can apply this. Here is 8n, n equal to 8 and selection of all words, but E is always occurred at first. E is always, so you can apply n minus 1 equal to 7 and r minus 1 equal to 7. 7p7 equal to 7 factorial. E is fixed for first and 7p7 equal to 7 factorial. Okay. Yes. Now you can solve this y. You can also fix y one way, and now remaining you have 7 ways, 6 remaining to fill. 7 ways, 6 ways, 5 ways, 4 ways, 3 ways, 2 ways, 1 ways. So you can solve by the fundamental principle of multiplication, or you can apply directly the conditions rule. Okay. Now for the second question, The words begin with E and end N. In this question, now another condition is applied. Begin with E and end with N. Now here is fixed. Here is fixed E and N. So you can subtract 2. Now you can fix like this. Apply in first condition. Here is only condition given for 1. Now here is subtract 2 because here is fixed occurred always two things. So apply first condition, but here now you can fix this 1. Now you can apply 6 ways, 5 ways, 4 ways, 3 ways, like 6 factorial. Similarly you get 6 ways. Now third question. The word begin with and end with consonant. The word begin with and end with consonant. In here is condition applied for consonant. Word begin with consonant and end with consonant. So here is we have 3 consonant and 5 vowels. So here is a way to consonant apply 3 and 2. So selection arrangement of consonant is 3p2. 3p2. R is given to you 2 because 2 selections are 2 arrangements are given. R is arrangements are 2 from 3n things. So we get 3 factorial. Now you can also solve by this 3 ways, 2 ways. Now remaining you have 5 ways, 4 ways, 3 ways, 2 ways, 1 way. Okay, and then apply fundamental principle of multiplication. Our remaining place of arrange letter 6p6 equal to 6p 6 factorial. Now you have remaining 6 ways. Okay, 6 ways, 5 ways. Okay. Now required number of words can be formed 3 factorial into 6 factorial equal to, by the fundamental principle of multiplication, we get 4320. Now second question is, this is for your homework, try to solve by yourself. In how many ways 5 boys and 3 girls can be seated in a row so that number of 2 girls are together? In how many ways 5 boys and 3 girls can be seated in a row so that number of 2 girls are together? Okay, now try to solve by yourself. Now third question is, in how many ways can 5 children be arranged in a row such that 2 of them, Ram and Syam, are always together? Ram and Syam are always together. In 5 children can be how many ways you can arrange where Ram and Syam are always together in a row? Now second is condition is 2 of them, Ram and Syam, are never together. Okay, for solve this question, first solve for Ram and Syam are always together. Similar like second question where number of 2 girls are together. So arrangement of 5 children where Ram and Syam are always together is, apply condition number 3. Apply condition number 3. The number of permutation of n different objects taken are at a time in which 2 specified objects always occur together. So 2 factorial r minus 1 into n minus 2 p r minus 2. Now arrangement of 5 children where Ram and Syam are always together equal to 2 factorial 5 minus 1 r equal to 5. Total number of children is n is 5, n r and r is 5, n equal to 5, and arrangement of all children, but Ram and Syam are always together. So 5 minus 1, okay, 5 minus 2 p 5 minus 2. Now we get 2 into 4 into 3p 3 factorial. Now 2 into 4 into equal to 48 ways. So now arrangement of 5 children where 2 of them, Ram and Syam, are never together, means total number of arrangements of 5 children in a row then minus when minus the all arrangements where Ram and Shyam are always together. Okay, you can solve this question by this way. 5 children arrangement where Ram and Shyam are not always together equal to total number of arrangement of 5 children in a row minus arrangement of 5 children when Ram and Shyam are always together. So NP5 arrangement of all children in NP5 5 factorial minus 48 from first of this question. 5 factorial minus 48, 120 minus 48 equal to 78 which 78 arrangements are possible. Now next question is how many even numbers are there with 3 digits such that if 5 is one of them digits then 7 is the next digit. Fourth question is how many even numbers are there with 3 digits such that if 5 is one of the digits then 7 is the next digit. Okay, I hope you understand this question. If you don't understand, I will explain you. Okay, just wait. Yes, how many even numbers are there with 3 digits such that if 5 is one of the digits then 7 is next digit. Yes, you can how many even numbers are formed when 5 is one of the digit then 7 is the next digit. Think how many numbers of even makes, let's suppose. Think and solve. This is very good question. Even numbers formed, how you can create even numbers of 3 digits such that one of the digit is 5 जिसमें कि 5 एक डिजिट हो और उसका अगला डिजिट 7 हो. Now a code word is to consist of two. Next question is a code word is consist of 2 distinct English alphabet followed by 2 distinct number from 1 to 9. For example, CA23. A code word is to consist of 2 distinct English alphabet followed by 2 distinct number. Means first 2 distinct alphabet to form a code word and then 2 distinct number from 1 to 9. For example, CA23 is a code word. So how many such code words are there? How many such code words are there? How many such code words are there? How many of them end with integer? How many such code words are there and how many of them end with a integer? Now, for making a code word, we require 2 distinct alphabet and 2 different number from 1 to 9. Arrangement of alphabet 26p2. Arrangement of numbers 9p2. Okay. Arrangement of first alphabet 16p2 means 26 ways and 25 ways and 9 ways and 8 ways for numbers and for alphabets. Now total numbers of code word is possible by the fundamental principle of multiplication. Apply 26 into 5 into 25 into 9 into 8 way 46,800 code words are possible. Now number of code word which ended with even integer. Now number of code word end with even integer. You can correct here question. Here is mistake. Here is right even integer. So now number of code word found which ended even integer. So how many ways you can even integer? So first here is 26 ways, 25 ways, 8 ways. Okay, because here is from 1 to 9 is a 4 ways to even number place Now here is a remaining 8 veg, because here is right one number, so here is remaining 8 veg. So number of code word found which ended with even integer is 4 into 8 into 26 p2. 4 into 8 into 26 p2 is 20,800 words code word found. Now sixth question is, now in how many ways can 9 examination papers be arranged so that the best and the worst paper never together? In how many ways can 9 examination paper be arranged so that the best and the worst paper are never together? Okay, you can solve by yourself. Now next question is, how many 4-digit number divisible by 4 can be made with the digits 1, 2, 3, 4, 5 if the repetition is not allowed? How many 4-digit numbers divisible by 4 can be made with the digits 1, 2, 3, 4, 5 if the repetition is not allowed? For solution of this question, first note divisibility rule of 4. Numbers are divisible by 4 only when last 2 digit is divisible by 4. For formation of this 4-digit number, be required when repetition is not allowed. We have 5 digit 1, 2, 3, 4, 5. We have n equal to 5. Now divisible by 4, we required last 2 digit making. What 2 digits are making in last 2? By using 1, 2, yes, divisible by 2, 1, 3, not possible, 1, 4, not possible, 1, 5, not possible. Similarly, 2, 1, not possible, 2, 3, not possible, 2, 4, possible, yes, possible. Now, similarly, 2, 5, not possible. Now, 3, 1, not possible, 3, 2, possible, yes. Now, 3, 3, not possible, 3, 4, not possible, 3, 5, not possible. 4, 1, not possible, 4, 2, not possible, 4, 3, not possible, 4, 5, not possible. Now 5, 1, not possible, 5, 2 is possible, divisible by 4. So, and 5, 3, not possible, 5, 4, not possible, 5, 5, not possible. Here is a 4 possibility of divisibility to make in 2 we can 4 numbers can, these 4 only 4 numbers can put to make divisible by 4 numbers. So you can put here e2 by 4 way 4 digits only. Okay, so here is a 4 ways of both box. Here is a 4 ways to put this bag. Okay, 4 ways to put arrangement in these 2 boxes. Now remaining, we use 2 words, 2 letters, 2 numbers. Then you have remaining only from 5 from 3 numbers and 3 numbers. So here is, you can put this when repetition is not allowed, 3 ways and 2 ways. So required number of ways equal to 3p2 into 4, 4 ways, and selection of 4 3p2 and 3 factorial into 4 by the fundamental principle of multiplication. Here is the 24 numbers can be created, can be made of 4 digits which is divisible by 4. Now next question is, find the number of ways in which 5 boys and 5 girls win in a row so that the number of 2 girls may sit together, all the girls sit together and all boys sit together. All the girls are never together. This is for your homework. Now next question is, a tea party is arranged for 10 persons along 2 sides of a long table with 8 chairs, or in each side 4 persons wish to sit one on one particular and on 2 on the other side. In how many ways can they be seated? Now next question, question number 9 is, a tea party is arranged for 16 persons along 2 sides of a long table with 8 chairs on each side, 4 person to sit on each side, 4 person wish to sit 8 chairs in each side. And now 4 person wish to sit on one particular and 2 on the other side. In how many ways can they be seated? Here is a tea table, tea party, iron, where 16% along two sides of table. Here is a table, 16% can be seated in tea party. But each side sit only 8% of this long table. But 4% want to sit side A, then 2% want to sit side B, another side B. Okay, so in how many ways can they be seated? So how many arrangements can possible? These 4% want to sit on side A, and this 2% want to opposite to the 4% on another side. So how many arrangements can be possible to sit all 16% in this chair? But here is bishop 4% to want to sit here in this side, in this side, in this side, not at same place 1 2 3 4, this side only 1 3 5 6, इस प्रकार like this way 1 2 7 8, like this way, not only like this way 1 2 3. I have just represented to give you understanding. So this 2% wants to sit this side opposite to all these 4%. Okay, 4% want to sit on seat side A. Number of arrangement possible 8p4. 8p4. These 4% want to sit on side A. 4% arrangements are possible. 8p4 arrangements are 8p4. Now similarly 2% want to sit this side. So these 2% arrangements are possible. 8p2. Now remaining 10% number of arrangement equal to 10p10. Now total number of required arrangement equal to 8p4 8p2 into 10p10. Now you can solve this. We get 8p4 into 8p2 into 10 factorial. Okay, now 10th question is, in a class of 10 students there are 3 girls A, B, C. In how many different ways can they be arranged in a row such that number of two of the 3 girls are consecutive? In a class of 10 students there are 3 girls A, B, C. In how many ways they can be arranged in a row such that no 2 of 3 girls, means no 2 गर्ल्स कभी भी 3 में से एक साथ नहीं हो, लगातार नहीं होनी चाहिए. ओके, इन अ क्लास ऑफ 10 स्टूडेंट्स देयर आर 3 गर्ल्स ABC. इन हाउ मेनी डिफरेंट वेज कैन दे बी अरेंज इन अ रो सच दैट no 2 of the 3 girls are consecutive. Okay, now permutation of objects not, this is for your homework previous question. Now talking about permutation of objects not all distinct. Permutation object not all distinct theorem. The number of mutually distinguishable permutation of n things, mutually distinguishable permutation of n things taken all at a time, of which P are alike one kind and Q alike second kind, such that P plus Q equal to n. Here is number of arrangement of all distinct things. Here is P is a similar kind of things and Q is the similar kinds of things. Now P plus Q equal to n. So its permutation is possible like n factorial divided by P a similar thing divided by similar thing P factorial divided by Q factorial. Now for proof, let the required number of permutation be x. Required number of permutation be x. Okay, permutation is possible of these things x. Okay, Now permutation P alike thing is replaced by P different thing. If permutation of P alike thing, similar thing is not replaced by suppose P different thing. So what is the permutation is possible? P factorial. So similarly permutation of A like thing, similar things don't replace with A Q distinct thing. Q permutation of Q alike things replace with Q distinct. When Q different things of permutation is possible, Q factorial. So now find the each one of X permutation give rise to, when each one you give the X permutation things, like okay, permutation equal to X into P factorial into Q factorial, X for X thing. Now each of these is permutation of n different things. Each of these are permutation of n different taken all at time. We know that a permutation of n different things taken all at a time is n factorial. So therefore n factorial equal to x into p factorial into q factorial. So x equal to n factorial divided by p factorial into q factorial. Hence proved. Now remark, the number of permutation of n different things of which p1 are alike of one kind and p2 are alike of second kind and p3 are alike of third kind and p are alike of rth kind. Now such that p1 plus p2 plus p3 plus p plus p4 equal to n is, then its permutation is n factorial divided by p1 into p2 into p r factorial. Okay. Now remark 2, the number of permutation of n things which p are alike of one kind and q are alike of second kind, remaining all are distinct. Okay, then permutation is n factorial divided by q factorial, like theorem first. Now remark 3, suppose r things are arranged allowing repetition. Let further p1, p2, pr be integers such that first occur p1 times and second occur p2 times, p1 times, second occur p1 times, etc. Then total number of permutation of these r objects to the above condition is p1 plus p2 plus p3 plus p4 factorial divided by p1 into p2 into p3 into pr factorial. Now here is given practice question. First question is, how many permutation of the letters of word apple? How many permutation? Apple. Here is same. P is same. Two distincts are not here. 2p are not distinct. N equal to 5. How many numbers of letter is 5? Required number of arrangement equal to n by factorial, because 2p are same. 2p are same. P are same. So 5 factorial divided by 5, 2 factorial equal to 5 into 4 into 3. We get 60. 60 numbers of arrangement from the word apple. Now, how many different words by using all the letters word Allahabad? In how many of them vowels occupy the even place, and in how many them both L do not come together? Here is a condition. Here is a question. First is very easy, and second question is with certain condition. How many different words can be formed by using by the letters of Allahabad? In how many of them vowels occupied the even position? And second, how many of them both L do not come together? Okay. Now solution of this question is Allahabad. How many numbers of word letters in Allahabad? 9. Total number of letters n equal to 9. And L, how many numbers of L? 2. And A 4. So L and A are same. two L's are same and two letters L are same and four letters A are same. Okay. Required numbers of word form equal to 9 factorial divided by q factorial. Okay. Okay. So you can solve. We get 7560. Now question, in how many of them vowels occupy even position? Now condition. Now solve condition. Occupy even position. Here is a box for arrangement of word Allahabad. Even position, even position, even position, even position. Vowels for a same words. So you can arrange all vowels in even position is one way, because for us required number of permutation of vowel in even position is 4 factorial divided by 4 permutation taken at all distinct things r equal to n and n equal to 4 or r equal to 4. So 4 factorial divided by 4 factorial equal to 1. If put 4a here, how many ways? You have 4a, all are same. So you can put this a in one page. So remaining arrangement equal to 5p5. Remaining arrangements are 5 factorial divided by 2 factorial, because you have 2l are same. Okay, then we have 60 ways. Now total required arrangement equal to 60 into 1. You have 60 ways to arrange this. Now similarly, second of this question, second solution of this question, in how many of them both L do not come together? Both L do not come together. Apply the permutation condition. Do not come together. Okay. n-1 p r formula. Okay. Let us consider both L are together. How we solve when both L are coming together? Okay. So now A4 are same, L2 gathers. Okay. Required permutation when both L are together. So n-1 PR. Okay. Now n-1 PR. n-1 PR. Now you can see this box. Both L are together. Here is possible when two boxes are same. Then you have remaining only 8 box. And when two you have becomes 8 box. Now here is 8 factorial divided by a factorial. 8 factorial divided by, you can get the 1680. Okay. Now required permutation when both L are not together. Total number of words in minus numbers of words in which both L are come together. So we get 5880. 5880. Now third question is, how many words can be formed using the letter A thrice, the letter B twice, and the letter C thrice? How many words can be formed using letter A thrice, the letter B twice, and the letter C thrice? Now fourth question is, find the number of arrangement of letters of the word independence. In how many of these arrangements do the word start with P? Do all the vowels occur together? Do the words begin with I, end with P? You can solve. This is for your homework. And next question is also for your homework: how many arrangements can be made with the letters of the word mathematics? In how many of them vowels are together? Now sixth question is: in how many ways can the letters word permutation be arranged if words start with P and end with S, vowels are all are together? Now seventh question is: there are 6 periods in each working day of school. In how many ways can one arrange 5 subjects such that each subject is allowed at least one period? This is for this all questions. Remaining question are your for homework. You can solve by yourself. If you're not able to solve, then comment in the comment box. Then I will give you explanation. Okay, thank you for watching this video. Please like, share, comment.